Alright, so this is your polar coordinates in test review. So we want to fire a shot at position 2 with a positive radius and a negative angle. Now if you look here, all 4 points have a radius of 3. So I'm going to write them up here so that thing doesn't keep popping up. So number 1, we know for a positive radius it's going to be 3. And for a negative radius it's going to be negative 3. So we can go ahead and write the first 3 of them with the radius for each one. Since number 1 wants a positive radius, it's going to be positive 3. Numbers 2 and numbers 3 want a negative radius, so they're going to be negative 3. Now, we need a negative angle. So, a positive radius means when you start here, you go toward your point. A negative radius means when you start here, you go away from your point. In theory, anyway, I'll show you what I mean. So for number 2, we want a negative angle but a positive radius, which means we're going to start here and go toward our point, which means our negative angle is going to have to start here and come all the way around to here. And whoops, I went one, I didn't go all the way to 2. So our negative angle here is going to be negative 300 degrees. Okay? Because that's our negative angle, it comes all the way around. So our angle is going to point in this direction. And then since it's a positive radius, it's going to follow that angle. Alright? Now, number 2, we need to hit point 3 with a negative radius and a positive angle. Now, negative radius means that we're going to be over here somewhere. Okay? With our point. You can think of it as like a phantom point. Okay? So we want to hit right here. Well, our negative 3 ensures that after we find our angle, when we do the negative radius, it goes up this way to hit our point 3. So we want a positive alpha, which means we're going to start here and go the positive direction around, all the way around to here, because this is the angle that we want to hit. And if you look, this angle is positive 255 degrees. All right. Now, number 3, we're hitting point 4 with negative negative. So again, we want to hit this point right here with a negative radius and a negative angle. So our negative radius puts us there. Our negative angle, we're going to have to be pointing straight down. A negative angle is negative 90 degrees. Okay? So there's 1, 2, and 3. Positive radius, negative angle, negative radius, positive angle, negative radius, negative angle. Now on the test, make sure when you look at these, that was terrible. When you look at these 3, make sure that you're finding the correct point, alright? Because here we have points 1, 2, 3, and 4, but down here, number 1 is finding point 2, number 2 is finding point 3, number 3 is finding point 4. So make sure you don't get confused tomorrow. Alright, let's keep going. Convert from rectangular to polar coordinates. So we want to convert 7, 9, which is rectangular, to polar format, which is r alpha. Okay? So r equals, because see here, r squared is equals x squared plus y squared. So r is going to equal the square root of x squared plus y squared. Okay? Alright, so the square root of x squared plus y squared is r. So r is going to equal the square root of 7 squared plus 9 squared, which equals the square root of 130. Now, you can either leave r as the square root of 130, because that is simplest radical form, or you can give me a decimal, which will be 11.4. I'll take either answer as correct. So this is going to be the square root of 130. Alright, that's our radius, comma, now we got to find our angle. Well, here we go. Alpha is the inverse tangent of y over x. So it's going to be the inverse tangent of y, which is 9, over x, which is 7. And of course, the 7 is negative. So just punch that into your calculator. And this is going to give you negative 52 degrees. Now, if you just go ahead and write that up in here, this is actually not 100% correct. Because what you want to do is you need to make sure that you're actually going to hit this point. Well, if you drew a coordinate plane, -7, 9 would be over here. -52 square root of 130 is here because the angle it gave you was this one, 52 degrees. Okay? So you can do one of two things. You can make this a negative square root of 30. Then that way when you find this angle, you go backwards and you hit that point. So you're good. Or what you can do is you can draw this angle up to it, because this angle here from the from the negative x-axis is actually 52 degrees as well. So you could either give me negative square root 130 with a negative 52 degree angle, or you can give me positive square root of 130 with an angle of 180 minus 52, which is 128 degrees. Okay, either answer is correct here. But if you use the negative 52, you got to use negative 130, negative square root of 130. If you want to use a positive square root of 130, you have to give me 128 degrees. Otherwise, it's going to be wrong. All right, moving along. Number 5, convert the following complex number from polar to standard form. So we want to take this and put it in a plus bi. Well, if you notice our formulas up here, a equals r cosine alpha and b equals r sine alpha. So a is going to be the square root of 2 cosine of 75 degrees, and b is going to equal the square root of 2 sine of 75 degrees. So now just punch that in the calculator. Now, when you first punch it in, if you're in math print mode, you're going to get something weird that looks like this. Alright, if you just hit that button above enter that kind of has greater than less than sign on it, it'll immediately convert it to a decimal. I'm going to write the decimal over here. The decimal of square root of 3 minus 1 over 2 is 0.366 plus. Now if you do this, it's going to do the same thing, except it should be plus 1. Yep, square root of 3 plus 1 over 2. Again, hit that button right above enter, and it'll give you 1.366. And then don't forget to put your I on the end, because this is a complex number, so it does need to have an imaginary component to it. Okay? Number 5, convert the following complex number into standard polar form. You can either use the shorthand, RCIS alpha, or you can use the longhand. I'm going to use the shorthand because they're the same thing, just one's a lot shorter to write. So again, R is going to equal the square root of a squared plus b squared. And of course, alpha is going to equal the inverse tangent of b over a. Okay, those formulas are here, right there. So r equals the square root of 5 squared plus 5 squared, which is the square root of 25 plus 25, which is 50, which equals 5 times the square root of 2. So our complex number is going to be 5 square root of 2 CIS. And now we got to do the inverse tangent of -1. Well, the inverse tangent of -1 is going to be, should be 45 degrees. -45 degrees. Now again, we need to make sure that we hit our point. -5, so let's draw this out. -5, positive 5i, we're going to be here. So if we use -45, again, we're going to be here. So we need to make sure that our angle is pointing in the correct direction. Since we know this is 45 degrees, and we know this is 45 degrees, we're going to need to find this angle here, which is simply 180 minus 45 degrees, which is going to be 135 degrees. Alright? So again, always check the location of your point with your angle and your radius to make sure that everything agrees. Okay? Or you won't get the problem 100% correct. Alright? Moving on. Where are we at? Number 7, multiply the following complex numbers. Remember, when you multiply complex numbers, you multiply the radii and you add the angles. So 8 times 7 is 56. CIS, 226 plus 70 is 296. So there's your multiplication. Now when you divide, remember, you divide these. 10 over negative 8. Okay, this is going to go to a 5. And this is going to go to, what, a negative 4. So negative 5 over 4, CIS, and then you subtract these two. So 247 minus 93. Remember, you always do the top minus the bottom. And it's going to be 154 degrees. If you want to write this as a decimal, be my guest, negative 1.25, CIS 154 degrees. All right. Now, we want to find the cubed root for number 9. So, remember, to find the cubed root, the first thing we do is r negative. Well, r is not negative, so we're good. So now we take the cubed root of 56, which is, I'm going to call it 3.8. All right, so 3.8. And remember, all of these are going to be 3.8, and we're going to have 3 of them because we're finding the cube root. So 3.8 CIS, CIS, CIS. All right, now let's find our angles. Remember, the first thing you want to do, 273 and divide it by 3, or 276 divided by 3. It's going to give us 92 degrees. Okay, so all I did was take, first thing I did was the cubed root of 56, which is 3.8, which equals our new r. So that's why all 3 of these are 3.8. Then I took 276, divided it by 3, and got 92 degrees, so that's our new alpha. Now we got to find our angle offset, which is going to be 360 degrees divided by 3, which equals 120 degrees. So now we're just going to go through it, adding 120 degrees to all of our angles. All right, so there we go. Remember, 92, you add your offset, which is 120, get 212, add your offset again, you get 332. Okay, you get 332. All right, find the result of the following. Yeah, I can't say that word. All right, so remember, this is simply 6 raised to the 6th CIS of 276 times 6. Okay, which equals 6 raised to the 6th is 46,656 CIS 276 times 6, which is 1656. All right, don't get these two confused. So this is just simply 6 raised to the 6th CIS, your angle times the exponent, so 276 times 6. All right, so there it is. Now, number 11, identify the polar equation graph. We have r equals 5 cosine of 11 alpha. Now, remember, this is a rose curve. Obviously, you can see all the answers say rose curve. Now, when this is an odd number, you simply have that many number of petals, the number in front of alpha. So this is simply a rose curve with 11 petals. Remember, if this was an even number, you'd have twice that many. But since it's not, you only have 11 petals. Now down here, identify the following equation again, 4 plus 2 cosine alpha. Remember, you have 3 types. You have 3 types of limacons. You have your inner loop, which is sometimes called a belly button. A will be less than B. Then you have your cardioid, which is heart-shaped, which is when A equals B. And then you have your dimple, or dimpled limacon, which is when A is greater than B. Okay, so in this case, since A is greater than B, this is going to be, oops, why did I start with that one? This is going to be a dimple limacon, or a dimple curve. All right? Make sure you remember this, because this is not on your formulas. Make sure you remember that, okay? So this has been your polar coordinate test review. You can feel free to watch this as many times as you need to. And make sure when you come to class tomorrow, you're ready to take the exam. See you tomorrow.